Hello, um, thank you for joining. What I'm going to do in this video, I'm going to tell you and show you a couple of examples of the innovations that are coming to the ACI network. So we're going to be focusing on some dual data center scenarios and the information and the innovation that Cisco is bringing for some of those scenarios. Um, my name is Chris Sekola, and this material has been prepared by me and a couple of other of my colleagues. By the way, the practical examples that I'm going to be showing you today are available for customers to validate in our customer proof of concept labs. The examples I'm going to be showing you today are built in the customer proof of concept labs in London. Quick disclaimer, this material presented here is potentially subject to change. So, of course, always check our website for most up-to-date information. So, we're going to focus on a number of scenarios, but the first scenario and the first most common scenario is a situation where we have two data centers with layer 2 reachability across sites. When I say two data centers, from the ACI point of view, I mean two completely independent fabrics. So we have data center 1 with ACI fabric and its own dedicated management cluster, so AP cluster, and we have a second data center with its own dedicated AP cluster. So those two are completely independent environments. They are cross-connected with some kind of DCI technology. The DCI technology that you could consider for this scenario could be anything as simple as this design option number 1, where we have a back-to-back or double-sided VPC that connects the border leaves or border nodes in the fabrics together. This could be utilizing dark fiber or DWDM. It's of course limited to the distance between the sites. The second design option is where we use some more sophisticated method of performing the DCI. So this could be using technologies like VXLAN to overlay the layer 2 over layer 3 networks. It could be something like OTV that cross-connects the data center. So the first scenario that we're talking about is the scenario where there's a layer 2 reachability between the sites. So for that scenario, what we're going to be doing is we're going to be performing a one-to-one mapping between EPGs, which are the endpoint groups in ACI networks that represent some kind of environment or some kind of connectivity. Those endpoint groups will be mapped to a VLAN, and using a VLAN, they will be transported to the other data center. So it's a sort of static one-to-one mapping between endpoint groups and VLANs that we are utilizing in this scenario. It's very simple. It's easy to configure. It's a static binding that we perform simply to extend the EPG towards the other data center utilizing a VLAN. Keep in mind, you have to stick to consistency. So if your endpoint groups are defined in both data centers, obviously they should map to the same VLAN to get the connectivity between the endpoint groups working correctly. So one thing that is already existent in the ACI network is the fact that it utilizes an Anycast gateway. So in this example that I'm showing you today, we see the two data centers connected with each other, and we see some endpoints. In this case, it would be virtual machines in data center 1 and virtual machines in data center 2. So imagine that all of those virtual machines belong to the same endpoint group called web. This could be my web servers. the virtual machines that are located currently in data center 1, they would be utilizing the Anycast gateway in data center 1, and the virtual machines sitting in data center 2, they would be utilizing the default gateway in data center 2. Now, this brings some challenges, and let me explain what the problem is. So imagine a situation where we have two sets of virtual machines. Some located in data center 1, some located in data center 2, but belonging to different endpoint groups. So imagine a situation where a virtual machine, the one here on the bottom left-hand side corner, 10.1.4.11, is trying to communicate with a virtual machine under the address of 10.1.6.12. So this is how the traffic flows. First, that virtual machine is going to try to communicate to the other virtual machine. It's gonna ARP for its IP address. This ARP is going to get to the leaf. The leaf doesn't know where the destination is, so he's going to send it to the spine. The spine is going to create an ARP request because the destination is on a different subnet. It's going to create an ARP request looking for the destination virtual machine. That ARP request is going to be originated from the SVI of the data center 1 Anycast gateway. So in this case, it's going to be sourced from 10.1.6.1. This ARP, of course, is going to be flooded. And by the way, for this to work, you have to enable ARP flooding on the bridge domain, which is not enabled by default. So that's a prerequisite to get those two data centers talking to each other. Anyways, this ARP is going to be flooded. It's going to reach data center 2, and it's going to reach the destination virtual machine. But when the destination virtual machine responds, it will respond to the IP address where this ARP request has come from, which is going to be the 10.1.6.1. So it actually happens that 10.1.6.1 is the IP address of the local gateway at the same time. So the gateway located in data center 1. That gateway will consume the ARP reply and will learn the local virtual machine, but it will not send the ARP reply to the other data center. So this is how this is a problem that we have to deal with. And the way we deal with it is for every gateway that we create in this environment, we put a secondary IP address that is used to source the ARP request by the fabric. Let me show you how it's done practically in the environment. So this is my two ACI fabrics, data center 1 and data center 2. Let's have a look at the bridge domain that that deals with this web endpoint group. So we can have a look at layer 3 configuration here, and what we see is that my gateway is defined by two IP addresses. One is the 10.1.4.1 and the other one is 10.1.4.253. And the 253 address is marked as preferred. What that means is that when the spines are going to generate the ARP request that flows to the other data center, that ARP request is going to be sourced from IP address 253 instead of being sourced from IP address .1. This will help. And will allow the ARP response to come back to the data center where it originated from. I can show you the same thing in data center 2. In data center 2, and I mean, it's the same situation in here. So if we look at the layer 3 configuration for our SVI, we have 10.1.4.1 and 10.1.4.254. The 254 is marked as the preferred address. So the ARP request generated by the fabric is going to be sourced with the IP address of 252. So that's one of the things that we have to deal with, and that will help us um, perform this cross data center communication between the endpoints. Going back to the innovation that we're trying to introduce in this environment, something that is kind of new and it's coming to ACI is the fact that now not only are we able to generate or to configure the secondary IP address that is used to source the apps, but what we can also do is we can configure a virtual MAC address. What this allows us to do is it allows us to um, it allows the virtual machines to vMotion between the data centers without having to re-ARP for its default gateway, because the MAC address of the default gateways are going to be exactly the same in both data centers. Once again, let me just very quickly show you how it's done and where it's configured in the ACI network. So going back to our bridge domain configuration, you can see that we have this new section in here where it says virtual MAC address. So we are able to specify a virtual MAC address for both of our data centers, and we use the same MAC address. So this is going to be the MAC address that's going to be used by the fabric. And if we look at our subnets, so if I highlight my .1 address, I can treat this address as virtual IP, which means it's going to use that virtual MAC address. So let me show you practically how this affects the traffic and how it affects the virtual machines. So we're going to log on. I'm already logged on to my vSphere environment. This is specifically vSphere 6.0. So in 6.0, you can, in the web client, you can get cross visibility between data centers. So I have, this is completely separate environments. Data center 1 has got its own vCenter, and that data center 1 vCenter is registered with APIC in data center 1. But we also have a data center 2 with its own vCenter, and that vCenter is registered with APIC in data center 2. So what we have here is a test virtual machine called TNT-14 VM02. So if I open the GUI inside that virtual machine, if I open the console of the virtual machine, and if I do ARP minus A, ARP minus D, let's clear the ARP table, or do ARP minus A. So we'll see that what we've learned is the IP address of our default gateway, which I'm pinging here, by the way. And this IP address is the virtual IP address that I've configured in ACI. So that virtual machine, I'll close the console. That virtual machine is currently located, as you can see, in data center 1. So I'm gonna perform now a cross data center, cross ACI fabric migration. So I'm going to migrate the virtual machine from data center 1 into data center 2. So let's do that. We're going to select the host that is part of the vCenter in data center 2. If you keep your naming of your endpoint groups consistent between the fabrics, this vMotion will automatically pick the correct destination network because it will match the name of the destination network. And we'll finish that. So we're going to wait a couple of seconds for this vMotion to finish. And once the VM is in data center 2, okay, it now is in data center 2. We're going to reopen the console, and as you can see, the only thing that we had to that we lost a ping on was the remote virtual machine that we're trying to reach. But our default gateway, we haven't even lost a single ping. we still are seeing the responses from the default gateway exactly the same way. And if I show you once again the ARP table on this virtual machine, the IP address of the default gateway is 10.1.4.1, and the MAC address is exactly the same as it was a few seconds ago. Just to prove that that even when it does a fresh re-ARP, it will get the same MAC address. I'm just going to clear the ARP table and display the information once again for you. So as you can see, it's got the same address. So that's one of the things that that is coming to ACI. Let's go back here. So there's another scenario where what you might have between the data centers is not a layer 2 extension, but a layer 3 extension. So some challenges there. Imagine a situation where there's no possibility to do a layer 2 extension. You only have a layer 3 extension between the fabrics. So in ACI, we have a concept of layer 3 out. It's a special type of EPG that provides connectivity towards layer 3 networks. So we have fabric in data center 1 with its dedicated layer 3 out for DCI connectivity, and we have fabric in data center 2 with its dedicated layer 3 out for connectivity to the other data center. So one thing that happens as part of this layer 3 out configuration, we classify traffic as it comes in. So what you can do is do a generic 0/0 classification and classify everything that comes in to be part of the to be allowed through the layer 3 out into the fabric. So as I said, in this case, my two fabrics, my fabric in data center 1 and fabric in data center 2, are cross-connected from the layer 3 point of view using BGP. Now, this cross-connection, this layer 3 cross-connection, can actually happen over a back-to-back VPC, but you might not want to extend all the VLANs between the data centers. You only allow layer 3 connectivity between the two fabrics. Regardless of which method you use for the interconnect between the data centers, there is a couple of considerations that you have to be careful about. So let's talk about a few of those. First of all, when we have a layer 2 extension, we need to keep consistency in terms of the configuration between the sites to keep all the contracts and all the security that you have in one data center consistent in the other data center. So imagine this situation that we have pictured here. We have fabric in data center 1, fabric in data center 2. We have an app EPG and a web EPG, and there's a contract between those two data centers. Each of the endpoint group is extended to the other data center. So for example, app endpoint group is extended using VLAN 301, and the web endpoint group is extended using VLAN 300. Now, what you want to be able to do is obviously you want to be able to enforce the same contract that you have locally in data center 1. You want to have the same contract in data center 2. So this way, if my web server that is currently sitting in data center 1 attempts to contact an app server that is currently in data center 2, it will be subject to the same type of contract and the same type of restrictions as it would be in data center 1. That's kind of easy to achieve as long as you keep consistency in terms of how you create and how you attach the contracts between the data centers. Now comes the more tricky part. So in the case of layer 3 connectivity, there is more than one contract that you have to deal with. So there's a local contract between our app and web tier, that's C1, and there's also a contract towards the layer 3 out. So the layer 3 out is what um, governs the connectivity over the layer 3 fabric to the other data center. Now, there could be a couple of situations, but in the first instance, we are considering a situation where our app and our web endpoint group are sitting in a completely separate layer 3 subnets. So in this case, I've got 172.10.2.1/24 for my app and 172.10.1.1 for my web, which means that as the traffic leaves and enters data center 2, the way I map the traffic to the endpoint groups in data center 2 is based on the classification on the layer 3 out on the way in. And if my source EPGs were completely separate subnets, it's very easy because I can classify on /24 networks. I can say 172.10.1.0 is going to be the external web tier, and 172.10.2 is my external app tier. So that's a very simple classification, and it's easy to implement. But what if we have a bit more complex scenario where and it's a very common thing that to perform those days in ACI. What if you're using a bigger flatter network or the same subnet for both app and web? You might think, how can you do that? Well, in ACI, you can use the same subnet for multiple endpoint groups. So you can use the same subnet and have multiple endpoint groups within that using that subnet, and you still are able to separate the traffic using contracts. So the machines can end up being part of an app endpoint group based on the association of virtual domain, and they can be accepted into the web tier based on assignment through a virtual domain. Now, if both of those VMs are part of a different endpoint groups but are on the same subnet, that classification of the traffic when it reaches the data center 2 has to be done on a basis of host routes. So they have to be a /32 routes. And this becomes really complex because that requires you to constantly change and update those /32 subnets on the remote side. It's impractical to be even considered. So there's a couple of things that we can do to challenge this problem, and one interesting method of doing it is to use what's called an ACI toolkit for multisite. Some of you might be familiar with ACI toolkit already. It's a set of Python libraries that have been written specifically for management of the ACI networks. As part of the toolkit, there's a couple of example applications. And one of the applications that you will be able to utilize is something called multisite. What multisite does, it allows you to register two data centers, a local and a remote data center. The ACI toolkit then registers for endpoint notifications on a local site, and based on those endpoint notifications, it will automatically program the layer 3 out on the other data center to allow that /32 classification. Let me show you how it looks practically. So let's have a look at the ACI toolkit configuration and what it's doing. So as I mentioned, it's a set of libraries, Python scripts that can be utilized. When you install the ACI toolkit, within the folder of the installation, there's a folder called Applications, and inside that we have this folder called multisite. So multisite is where all the clever bits are happening. Multisite requires a configuration file to configure its functionality. So this is how an example configuration file might look like. Within the configuration site, you define what's called a local site. So a site where the local flag is set to true. You also configure a remote site, and then what you do is you specify the EPG that the ACI toolkit should monitor locally. So that's the EPG and also actually also the application profile. So we are telling the toolkit to monitor this application profile and this specific EPG and look for changes, so for hosts being added and removed from that EPG. The next one is the remote layer 3 EPG that the ACI toolkit is going to be configuring, and the tenant name. The rest of the configuration is what's applied in Data Center 2. So we have to specify the site name, we have to specify the tenant name, and we have to specify the layer 3 out that we're going to be modifying. So that's the layer 3 out that we're going to be modifying, and we also have to specify the contract that's going to be applied to that layer 3 out. So let's start the ACI toolkit. So Python, that's the name of the script, and that's the parameter, which is the configuration file. So once started, you can do show sites, and you can see that both sites are connected. So Data Center 1 and Data Center 2 are connected, so the monitoring will happen. And if we log on to the APIC for 1 second, I'll show you what we're doing. So we are monitoring this endpoint group. So if we look at endpoints within the endpoint group, at the moment there's none. Okay, so on the remote side, what we'll be modifying is we'll be modifying a layer 3 out, and that's the layer 3 out. So by the way, it's the at this level is the layer 3 out definition. So that's the layer 3 out definition, but there's the special EPG that maps to that layer 3 out that the toolkit has just created. We've given it this name, so the name here is actually specified in the parameters of the configuration file, and this is what the toolkit is going to be modifying based on what's going to happen in Data Center 1. So the moment there's a new endpoint group registering in Data Center 1, the toolkit is supposed to come here and automatically create a /32 subnet or mapping of a /32 host into this layer 3 out. And this will allow it to apply a contract to the traffic as it comes from Data Center 1. In this case, we have a contract between app and web that allows RDP as an example. So it would have to be normally a manual operation, and if we're dealing with /32, that would be impossible to manage. So this is where the toolkit is going to help us perform this this operation. So let's try to introduce an endpoint in Data Center 1. So I'm going to go back in here to my VM environment, and I have 2 virtual machines that will be in Data Center 2. They are at the moment disconnected from the network, so I'm just gonna change the settings. And I'm gonna select the network that is being monitored by the toolkit. So that's my first VM. I've just plugged it in. Let's have a look. Have a look inside. Try to maybe ping my default gateway here. 114.1. Okay, so my default gateway is responding, which means that this VM is connected. Let's for a second look at our data center 1. We can see we now have this this endpoint discovered in data center 1. It's been learned through the VMM integration. We know its IP address, we know its MAC address, we know the name of the VM. So what should now happen is we should see, and as you can see, this already has happened. We should see that endpoint being programmed on the layer 3 out in data center 2. So this happened automatically, and it will be registered and unregistered dynamically as the VM comes in and out of the endpoint group. So just to show you, I'll do one more. Edit settings. We'll plug the second virtual machine. And you will see how dynamically this gets provisioned. So as you can see, it's just popped up. The ACI toolkit has reprogrammed the layer 3 out to allow this this classification of the traffic as it comes into data center 2. So I hope this was interesting and useful. Feel free to leave us some comments and leave a like if you liked the video. Thank you.